So, all right, hello everyone. Can you hear me? Okay. So I'm Daya from Ericsson, and this is my colleague Prem. We're going to talk about generic network functions. So this is more of a feature to enable multiple services to coexist in a nice way, cooperate with, build a design that enables application coexistence at the very basic level. So let's start with what are some of the challenges that we see in enabling this functionality, right? We'll start with a very open flow specific approach because that's how the VPN service is implemented today. It's the southbound is mostly based on OVSDB and OpenFlow. But having said that, while we use OpenFlow as a use case, it need not be restricted to OpenFlow. The way we see this interface manager functionality implemented, like Andre's proposal has, you could have different southbound renderers, for example, to implement the constructs in the plugin and the device layer. So interface manager could be a very central part of the renderer framework, for example, right? So what are some of the feature challenges we see from an OpenFlow perspective for multiple applications to coexist? Today, the way it works is every application defines its own space for all the resources. For example, you have flow tables, groups, meters, cookies. Those have to be very statically allocated and assigned across different applications that need to work in the same pipeline. And then this table zero problem, right? How do you enable different services to work together on a port? Who do you give which pipeline do you invoke first? Who do you, when a packet comes in from an access port or a trunk port, how do you decide which application gets that packet and processes it, right? And how do you do the handover between different applications? So if you have multiple applications working on a single port, how do you hand off the packets between different applications? So there's no clean way to do that today in sort of a more generic manner, right? So you basically, without any direct coordination between the applications, today you cannot really achieve this. All applications need to be aware of every other application and need to handshake with each other when they have to enable different services on the same port. Another use case is if you need a smaller granularity than an OF port. So for example, you might have 2-3 different applications working on a port, but they all need to have different abstractions of the port available. So to us, a port could be an OF port, or you could have VLAN trunk ports enabled. And some applications may need that VLAN awareness view from the port. Some might not need it. Some might work at a device port level. So you have different layers that different services need. And the interface manager that we discussed can enable some of that functionality as well. And then you have the issue of multi-tenancy. Now you may have one service supporting multi-tenancy and providing that through a common service, or you may have different instances of the service for different tenants, and you somehow need to enable that on your physical infrastructure. So there's different flavors of multi-tenancy that may need to be supported. So how does that work today? So in the control plane, you have service APIs that are directly enabled between the applications, right? They need to sort of talk to each other to enable some of these features. And in the data plane, the packets are transferred directly from the pipeline of a given application to another application, right? So there is very tight coupling at the design time that is needed between these applications to coordinate how packets are transferred between them. And lastly, another problem we see today is that every application has its own overlay. So if you have multiple applications that need to share an overlay or the infrastructure. There's no good way available to do that today. So we are trying to address, some of all of these issues through the, features we are going to present today. Prem, please feel free to jump in anytime. So today, yeah, go ahead. Yeah.
I have a question that you go back on.
Sure.
What kind of, how granular are you thinking of making that egress multiplexing? I think, for example, in the SFC and network, they're even sharing the same overflow tunnels, or the same vehicle and tunnels, and it differentiates between, well, does it have an NSH header? And even in some cases, some NSH packets might go to the underlay, the overlay manager, and some might go to the SFC based on the service path events. So that's like more granular than
correct.
The typical port level.
Port level, exactly. So I have a slide on that, but to answer your question briefly, it's very flexible. We are using the ITF Yang model, and in the Yang model, you can define a hierarchy, and you can define a parent interface, child interface sort of concept, and you can go as granular as you wish. So it's just a matter of defining a new type of interface and its correlation to its parent or child interface, and then every service sort of works at its own granularity. So it would be sort of an extensible framework depending on what the application needs. But we can, yeah.
Like I'm saying, so does that, so even if you extend it, or augment the model, your specific service stuff, does part of the framework, I guess, the interface managers, does it have to understand that?
Yes.
At least enough to multiplex it?
Yes, correct. So the service would request to bind to a certain interface abstraction. And of course, the interface manager needs to be aware of what level of interface it needs and create the appropriate hierarchy as needed by the service.
So one other thing is, as she was mentioning, that the service binding is an important part of this whole construct. Right? So what happens is, one is you define the interfaces, right? And then the services, whatever the services you talk about, right? The services within them would have further categorization. Right? For example, let's take L3VPN service, right? So L3VPN service as such would have specific constructs, right? Wherein you can go up to the level of detailed constructs or attributes, and then you can define the association, right? So what we do is, when we started the model, pretty much started with the interfaces as well as the service binding, right? So then we evolved it in a way that we have our own set of homegrown tools that would essentially provide you the detailed level of granularity depending on what you want, right? For example, down the line, you may also want to associate with security needs, right, based on an OpenStack type of deployment, right? So then you do have coupling with those type of constructs, where you can say, yes, this particular port may belong to this bunch of things, and you can do whatever you want.
Okay.
So that would then include, I mean, you could then, in your particular service implementation that you have there, that could include open flow matches that you could provide. Right?
Yeah.
Let's table that thought, because let's see what the construct is, and then we can answer these in more detail.
There are multiple parts to it. One is, of course, we are attacking the table zero or the app coexistence issue. Other one is the definition of these interfaces, and the third one is for the creation of tunnel and then association.
Yeah. Okay. So today, I mean, please correct me if this analysis is wrong, but today the way you see it is you have a design level differentiation or partitioning of resources between different projects. For example, this is probably what you did for the SFC integration for OVSDB, right? And then you have a design time coordination between the two services to figure out when packets need to be handed off to one pipeline versus the other, and on what basis do you do that. So while this can give to, this can lead, so at the control plane level, what that basically entails is that you have service APIs between the applications themselves, okay? And in the data plane, you have direct transfers between application pipelines. So every application that hands a packet over from its own pipeline to the next needs to know what the next application needs, how to present the packet to the next application. So there is a lot of awareness between these applications that needs to be built in, right? So while this can lead to an optimal solution for a specific group, as the number of applications you want to support grows, that the complexity of that, just increases and balloons, right? You need to now, every time you add a new application, you need to figure out how it works with everything else and how to do the handover between them. So what we want to do is to remove some of these hard-coded dependencies between the applications and also make it scale, make it a bit more standardized or generic, such that you can easily or more easily add, or at least that's a dream, that you can do this a bit more easily. Some more description of what we want to achieve. So we want to be we want multiple applications. We want to prevent multiple applications from writing into table 0, basically, and directly. But we want to be able to do this demultiplexing in table 0. Today, the flow conflict detection mechanisms that we've seen, there's some work going on in the OpenFlow plugin project, for example, for multi-writer issues. But they are a bit limiting in the sense that they do not allow for overlaps between flows. So for example, on the same port, when you have multiple services operating, and for example, classifiers, if you want, based on the classifier to do different things for, or send the packet to different applications, that's not very easily possible using the OpenFlow plugin based mechanism, because that's just a bit far too down the chain to achieve, right? So what we want to achieve is that you want to have this refinement and the demultiplexing to happen, much more flexibly. You want to be able to send it to all these applications easily, and you want to do it at more of a semantic level than at a flow level, because in a flow it's very hard to determine. For example, there's no priorities amongst flows today at the plugin level, right? Any application writing its flows can just, the flows can get sprayed any which way into the space. So there's no priorities, there's no way to determine which, how to do conflict resolution at the flow level. So you want to achieve, some of that much before it, actually goes down into the OpenFlow level. Okay, so how do we go about it? I mean, we have some utilities in place in the VPN service, and we believe that can help, achieve some of these goals. And I'll briefly talk about 4 of them. One is the interface manager utility, which primarily solves this or tries to solve the table 0 issue and allow for application coexistence. Then there's also some more, for example, a common overlay tunnel manager utility, which can give you a shared overlay concept.
Just to summarize the table 0 problem, it's like we are having 2 problems here. Right? One thing is handing over the packet from one traffic from one application to another application. That is one problem. And the second problem is that we are trying to figure out the overlapping flows. If there is an overlapping flows or there is a conflict literally, then we want to give them a priority that we
Correct. Correct.
Now, then I just wanted to clear that.
Yeah. Okay. So
The other issue is third issue is that if there is an interface underneath, for example, you may have one pass you would have one flow, and the second pass may again need to have a different type of processing.
Okay, so the interface manager will try to do this support for cooperation between applications with a minimal amount of design time coordination, okay, and move this coordination more towards the runtime as compared to design time, and have some generic infrastructure API so that you avoid some of the direct coupling. You do it through this other central broker sort of entity that's without having the direct coupling. But at the same time, wherever you need performance, it doesn't preclude you from, going ahead with the direct coupling if needed. And towards that same goal, we want to extract some of these common utility functions out into this framework, the new project framework, which is generic network services. And some of those would be this overlay tunnel manager, which is basically a common overlay service that can be used by different applications. So you have a shared overlay, and all the applications will sort of share. So today, network has, for example, has all the services using one overlay. But if all the services, for example, came from different projects, right? How would you still go ahead and share the same overlay for allow them to share that overlay? So towards that, we have that, you extract that out as a separate service and ask applications request that service from this common entity. So that would be sort of the idea, right? ID manager is one utility which can help you with resource management. So your tables, groups, meters, resources, as well as in the data plane, you can have different tags for your interfaces that give some unique metadata information to the applications. So that's sorry.
What does the ID manager do?
Yeah, so it's a very, I have a slide on that, but it's a very generic, unique identifier management sort of utility. Okay.
You can generate, you can request a unique UID.
Correct. So there's two modes in which it can work. I can go into more detail about it, but
Cross-cluster?
yes, yeah. But it can help in this metadata sharing between applications. When you have multiple applications working in the same pipeline, what Interface Manager does is it uses this ID manager and it gives a unique ID for each application to work on the same interface or pipeline. So every application gets its own independent sort of ID and works on that ID and specifies its actions on that ID. Okay. And Interface Manager is responsible for coordinating all these IDs and applying them on the southbound. So so basically Interface Manager is dependent on ID Manager today, the way it's written. So if we had to just sort of move that whole thing over into a generic utility, it would be part and parcel of that. You would need to move both or none. MD-SAL util is sort of a wrapper function we have that again Interface Manager is using today, so we want to list that here. It's just some support utilities that if multiple applications need to do the same sort of actions with the MD-SAL, we've just extracted those out as some common functions. So I just have one slider to go over that. But there is a dependency between ID Manager, MD-SAL util, and Interface Manager. So just wanted to bring that out, that the functions would have to be today the way they're implemented, they would all have to sort of move over. So I want to come up with a look at the VPN service use case and how this is being used today, just to sort of go explain where it fits in the ecosystem or where it could fit in the ecosystem for from an OVSDB perspective as well. So you have the sort of neutron modules here, right? And today in the VPN service, we have an ELAN or L2 service which services the L2 API for neutron. And today our L3 as well as VPN are both serviced by this sort of L3 VPN entity. We've combined L3 and VPN into one. And this is the BGP management entity that this is another part of the VPN service.
The BGP VPN is basically the Neutron or the OpenStack project, which essentially provides you the APIs for creation and association of VPNs in OpenStack. And it basically lands on the Neutron outbound, and that's why it's mentioned. And it uses the L3 VPN as the underlying thing to configure.
Correct. So
the VLAN services, as she was saying, the L2 services needed for any of the data type of deployment.
So today all these components are part of the VPN service, and our proposal is to move some of these underlying components into generic a network functions utility so that they can be shared across all the various projects. Okay, so this interface is sort of a central entity which basically whenever all these applications want to do anything with the underlying infrastructure, they register, they bind themselves to this entity here. So ELAN as a service would bind to a given interface, and so would L3. And in network case, if we go to this model, so would DHCP and ARP, and all these would be independent services, and they would all bind to different interfaces in the interface manager using interface manager API. Okay, in the run times, right? So at any given time in the runtime, you may have 1 or 2 or 3 or 4 or 5 services working on the same interface, and dynamically you would assign resources to those services. You would basically decide on how the flow would be between those services based on a priority, either a preset priority, or you could even move to a dynamic priority sort of mechanism. Yeah.
Dynamic aspect of it, it's a priority is always is statically assigned to this application, or is something which they dynamically can do.
Correct.
If you do dynamically, then how basically you resolve the conflict, because everybody will say this is my in dynamic
Correct.
nature.
Correct.
Everybody can come up with the same
Correct.
priority and say, okay, I need the same
Yeah.
priority, and there is a conflict. So how you decide this?
Correct. So today it's very static today. It's no different from how, for example, how network would do it. But there is one difference in the sense that in network pipeline you basically go through every module, right? Whereas here you look at which service is bound to it, and then you go according to priority. So for example, if there is no L3 defined at all on that interface, it will straight away go to the L2 pipeline, right? The incoming packet will directly go to the L2 pipeline. Or if there is no VPN defined, for example, then it will straight away go, depending on where the priority is, it will straight away go to the next.
So
The
I
next
just
service.
Yeah,
just
yeah,
wanted to
yeah.
comment on that.
Yeah.
Currently, the way network does go through every table, but it doesn't have to. I mean, you could know that certain services aren't configured, and you can just skip over those tables.
Correct.
I mean, it's good. That could be an option.
Yeah.
In the given current model.
Yeah, well, it's
Yeah.
like we should anyway, like matching
Yeah, yeah.
happens one more time, right? If there is something to you just that is very deterministic flow which you are keeping, right? Optim, if you want to make it a dynamic nature, there is always give and take in there, right? But it's just that you always go through the pipeline. That's
Correct.
deterministic way approach.
And going further along that priorities discussion, right? While we have static priorities today, you could introduce a certain, not like a runtime level, but you could make it a bit more fluid by defining, for example, a Yang model, where every service can be new services as they're added. You can add them in the priority list, right? In a hierarchical list, and then the interface manager can read that prioritization list and assign resources in the runtime accordingly. Right, so that level of dynamism could be added very easily to this framework.
The applications generally have a kind of static priority, they are routers, right? You have an IP address on it, but you want to apply ACL still. You would want to apply ACL before doing IP for forwarding, right? Because I want to drop the packet bit to source IP. So in that sense, ACL always comes before IP for forwarding. So that's how we see application as of now. Yes, that can make it dynamic.
For that, your interface manager needs to have a context on the application.
Yes,
right?
correct. So that could be that. I mean, today it is static, but you could make that as sort of a config model or a Yang model separate.
That's
Yeah,
what I'm saying. So
correct.
if you want to introduce a dynamism into it, there
Yes.
should be some static preference should be.
Yes, correct, correct.
That how it actually provide that,
Yes, yes,
Now, eventually, if somebody has a static information based on it, it actually giving you the priority.
correct. Yes,
Cannot be 100% and.
it cannot be 100%.
So,
Yeah.
so that's where I think, because most of these problems where multi-item comes
Mm-hmm.
when you kind of try to bundle many applications.
Yeah, correct.
But that is probably fine because it's come under when vendors ship their product out and they say,
Correct.
okay, we need this application, but the problem is the code that is in a wrapper that actually uses specific item. We use
Exactly.
right? We don't really worry about this thing in network, right?
Correct.
Okay, we just use this average whatever the mid priority and we use it.
Correct.
Because we are assuming in a certain environment.
Exactly. Yeah.
Now the point is, here it is all static, right?
Mm-hmm.
And the dynamism is very hard to introduce, I would say.
Mm-hmm.
The kind of dynamism we need. Then that's where it's kind of come to a packaging problem. The same thing happened with the flow writer which we are doing in open.
Correct.
plugin, right?
Yeah.
So eventually it's a packaging exercise. Now the point is, Because as of now, all the module use their own priorities.
Right.
Give them a priorities that this is your priority and use it.
Correct,
Okay?
yes.
Because then I would say is more of a kind of packaging problem there. Okay? But
Yeah, but at the same time, instead of doing that statically, right? If you do it using API from that the interface manager doles out, right? So let's say you have that relative prioritization between services in a static manner in one place, right? But if the services themselves in the runtime are not aware of it and they are doled out a priority by the interface manager in the runtime, and accordingly the resources are allocated, the tables for example, right, are allocated in the runtime by the interface manager, then you get a little bit more coordination between them, right? As new services are added, you just have to update in one place, and then in the runtime interface manager will sort of handle how you don't have to have fixed table assignments, for example, for services.
So the idea
Right?
is if you develop it around the interface manager, right? The applications tend to provide the information, and the interface manager is going to be the one who is going to probably do the
Distribution, resource management, right? Basically, how are the tables allocated to different services? In what sequence will they be executed? So all that can be done in a runtime manner, and applications are sort of decoupled from being aware of each other, right? They only talk to one. It's sort of like a broker in that sense, right?
Because at the end of
Yeah.
the day, most of the applications are going to be revolving around the interface, right? And then association of interfaces with the services, another key thing.
And another aspect of this is, let's say we have our ELAN service, right, and we don't merge the pipelines. You have complementary services that work in the same space, so network L2 versus ELAN, right? You could decide to put them in the same group, priority group, and pick one, right? So let's say in the runtime, you either pick network L2 or ELAN service from VPN, and you deploy that in the L2 space, and same for L3. So you could mix and match between different services in the same group from different project, right? Different projects. So that could also be possible using this framework. So you just have to define that in some sort of a modeling framework as to which category does my application belong to, and how does it fit in with relative priority with other applications. If you have a central, sort of file or Yang model where that's defined, then everything else can be pushed into the runtime. Right? So that's sort of where it comes into the picture.
So you mentioned early on about services, like ARP.
Correct.
If I never implement ARP, is there a way that through this interface manager you can package up an ARP service and never can use that? Or
Yes.
to me, that seems like a bigger. I mean, it's one thing for everybody to have their own application and be able to write, but it seems to me the better thing is everybody use the same services.
Yes, exactly. So both go hand in hand, right? When you're looking at network re-architecture, you would have to break up all the services as independent services, okay? And then if you use the interface manager construct, then every service registers itself with the interface manager, okay? And then you basically you can arbitrate as to how all those services are going to coexist through this through service bindings. So you would have to do both, of course. I mean, yeah.
Is there a way to influence the way the service is implemented? I mean, you kind of you provide ARP.
Right.
Is there a way to change it if needed by the application? Does the interface allow that?
Not right now, I think. I mean, it would need to be written to comply with these APIs for it to play nicely with in this framework, right? So I don't know. I mean, you need to think about that some more. Yeah. So this would be, for this multi-writer issue, you would basically use maybe migrate SFC over to using interface service bindings, network some of these, you break it up into different services, and each service registers itself with this, and similarly from the VPN, for example, if this, or this could register itself, then you can have like a uniform pipeline across all these services, that a seamless pipeline, and these would be more internal utilities. So today, for example, interface manager has a monitoring utility for controller driven monitoring of, for example, service function monitoring, right? If you need that function, You can use, we also have an ICMP implementation and or RPing based implementation here. So you could use that for monitoring your service functions. We've had an implementation where we didn't have OVS BFT support, so we've
Monitoring, would that be on the network
pings
level?
basically, yeah. I mean, if you wanted to, you could use different things. So this monitoring service is a generic utility, and while this shows only ARP and LLDP, we also have ping support in there, right? So you could request a monitoring session where you could give, either two interface endpoints, or you could give an interface endpoint and an IP node, like a service function IP. And you could just give it some parameters to monitor the availability of that service function.
Availability, or when I think of monitoring, I think of like network utilization or something.
No, this is more of an availability, keep alive sort of, yeah.
Availability, and
It's
for
a,
example, today we use it for tunnel monitoring.
Yeah.
If the tunnel goes down, then you need to probably generate certain traps or alarms.
yeah. So wherever the controller needs to do the monitoring functionality, you could use this so for non-BFT use cases basically.
Or you can get into like maybe a bit more of a concrete case of how the application coexistence would work between SFC and network, or because I'm curious how. I mean, I get it that okay, you're going to handle the table 0 for us.
Correct.
The SFC pipeline, for instance, I think has five tables.
Correct. No,
So
I'll.
it would then handle table 0, but how do I know where to write to the rest of my tables?
We have the framework for it, but not, it's not very well laid out from, but we can discuss that, just whiteboard. We have something here. Let's go through that first, and then we can circle back to how exactly it would map for SFC.
So the other
Yeah.
thing that's question I have is talking about decomposing this, or let's say our pipeline into different services.
Mm-hmm.
It seems like I think it's have you figured out how you're going to stitch them all together? It seems like that's a
Yes.
challenge.
No,
So
that's
one
yeah.
thing is solve the table 0 problem.
Correct.
Just have different applications register for what packets they want to receive, and then they
Correct.
go off in their own pipeline.
Right.
But it's hard to, and then we've, like, between Netbird and SFC and GBP, we've kind of worked out
Correct.
how to hand off between, back and forth.
Correct.
But, it seems like that's going to be hard to do to really share.
We have, that's the same thing that I was just telling him. We have the framework for it, but let's go through that, and then we can circle back to how exactly it might work. But I do have the next slide actually shows that. Yeah. Okay. So just to complete the picture here, it uses this ID manager utility, which I'll go through in a bit more detail. But that's a central part of some of this demultiplexing framework. And MDSAL util is just some utility functions for MDSAL operations. So yeah, I mean, I already talked about some of this. It supports hierarchy of ports. You can have different hierarchies of abstractions available on the same port for depending on what the application needs. And it's extensible to different types of interfaces, based on future needs. The model itself is quite extensible. There is a tag system, which that ID manager utility provides, which gives a unique identifier to every application in the control as well as data plane. So that's sort of important. Even in the data plane, you can use this metadata to carry some of this application specific information based on some tags that the interface manager would provide. Okay. For the table 0 problem itself, it will basically take over ownership of this table 0, okay, and possibly additional tables which I'll talk about, okay. And applications bind to these interfaces through interface manager APIs. Okay, there's no direct communication between applications. Everything binds itself as a service to a given interface or a set of interfaces. Okay, and they also register certain application specific instructions or actions that the interface manager needs to apply. So whenever interface manager needs to give a packet to an application, the application can specify what sort of actions or what metadata it needs from this interface manager. And this is also used between applications for handover, right? So you can basically decide what metadata to put in before you hand it over to the next thing in the pipeline. Okay, and every service is assigned a separate handle, which is this tag here. So there is, you reduce the risk of interference between different applications for ingress traffic. So while we are using OpenFlow as the base use case, the framework itself can be southbound protocol agnostic. I mean, like we discussed, we can use OVSDB as a southbound renderer for hardware VTEP, or we can use netconf for devices that don't support OpenFlow. So all those things should be possible. While we don't have that in the implementation today. Today it's very OpenFlow based, this implementation. And it provides tunnel monitoring by working with that monitoring service which I just talked about. It handles encapsulation and output at the egress as well. So when a packet comes, so from egress I mean the transport tunnel. So when you get a packet from a transport VXLAN tunnel, you could basically decide service priorities even there and apply different actions on packets. So, excuse me, how is this laid out? So it uses the IETF basic Yang model, which is all these dark, black colored constructs here, okay? And we define this hierarchy for interfaces. So you could have, an OF port which could be a VLAN port, but if you need that granularity of different levels of port, you could basically define it in this manner. You could define an OF port abstraction, then a VLAN trunk interface. On this VLAN trunk, per VLAN basis, you could define like a VXLAN tunnel interface, or just a VTEP interface, which would be this VLAN member interface. So you could basically, every application could work at different levels of this port hierarchy. And this is flexible because the IETF Yang itself, if you look at it, where is it? Yeah, it has basically these lower layer and higher layer interface constructs, okay. So you can define basically a hierarchy of interfaces in the IETF Yang itself, right? And come up with relationships between, all these different interfaces. Anything else I wanted to call out here? So this is basically what is in the interface manager model today in the VPN service, and of course this can be updated based on the needs of various projects.
So this is, if I see this diagram, right, there is no conflict or overlap of a traffic here, right? It's like you install a specific flow and then map a specific traffic and then route it, right? So,
Not really, yeah.
Arrive over a VLAN, okay, and you may want to do service chaining on it, classify it and do service chaining. But if the service chaining doesn't work because it didn't match the classifiers, okay, it will fall to the next service, which is probably L3 forwarding. Okay. But packets may arrive on the same VLAN, right? I mean, they're bound to two services. Now they may hit the SFC or whatever service chaining, and then they get classified and maybe get stored up from there and get service chained. They may go out, or they may come back to the L3 service, the next service, or L2, whichever.
So in the control plane, if you think about it, right, the reason for having this, so you think of tunnels, okay. So your L2, L3 services might bind themselves to tunnels for transport ports, saying I want to see all the packets that come out of these ports, and you tell me what VNI is coming from this tunnel, for example, right. But at the same time, you might have like a diagnostic application which wants to work at this level, right. So it will see the interface at this level, not at the tunnel level, right. Then you might have some other physical topology application which only wants to see the trunk interface or this OF port on a physical device. It may not be OF port, it might be a device port, for example, right. So on the same physical port, or if you just look beyond OVS for a minute, if you're looking at a physical switch, for example, right, you may have different levels of logical interfaces defined on it, and different applications would consume different parts of that port, right, different levels of information. So you can either model, the challenge with modeling this only as OF port is, then you're bound to one way of looking at it, right. So today the way we do it is all tunnels become OF ports, right. But what if some application is only interested in the VTEP, or one layer down, what is under the VLAN, right. then how do you give that information to that specific application? So that's where this comes in. I mean, your OF port could be anywhere along here, but your interfaces could all be different, right? In that same on that same construct. Okay, so we can go into this a little bit more detail if needed later.
This is the most important thing.
Yeah, you want to talk about?
So, wherein the ability to define the services, and then
Yeah.
you can give priority, and then you can also go to any granular level and then define what you want. So this is the key part of it.
So today we have these, for OpenFlow specific implementation, we have an opaque set of actions that the service asks the interface manager to do, right? When the packets traverse the pipeline before they are handed over to the service pipeline. But this can be, made very generic and abstracted out with different southbound renderers, for example, right? So the OpenFlow renderer would basically, convert those abstract actions into this instruction list. And for OVSDB or netconf, it might be a different way of actually implementing those actions. So today that framework is not there, but it can be added. The northbound is fairly abstracted out. The southbound is not, that clean yet.
And again, these two things are the main things.
Yeah, so to talk about how to hand off between applications, which we discussed a little bit earlier, right? We have something called a service dispatcher table, which regulates the pipeline between services. Okay, and
If something changes, right? So there is a
yeah.
instance of the service point changes and
Correct.
accordingly programs if there is a change.
Right.
Programs.
So yeah. So how does that work? So this is how the InterService pipeline framework works, right? So sure, yeah. So this is basically to handle in the runtime, right? Yeah. Correct. So data plane can be updated based on service bindings in the runtime. Yeah. So how does this work? So let's say the packet basically enters the OF pipeline, and in table 0, you come up with, based on your priority, you come up with the match for it, and what is the highest priority service to apply. So this service index is basically a per service priority, and you go through 0, 1, 2 in order of hierarchy. And how that is handled in the control plane could be either static or could be based on some Yang model or whatnot, right? But in the data plane, it basically translates to a hierarchical, linear priority between services. Okay, and there's this service dispatcher table, which every service is sort of independent of the dispatcher table. So these two are maintained by the interface manager. Okay, and every service its own pipeline is contained within this block. So they are all fairly independent of each other. Okay, so the interface manager will look at the first service. Okay. It will put some metadata in there, which when the service bound to the interface, it had specified what metadata it needs, and that's what it would put an index in there, as well as any other metadata that is needed by the service. Okay, based on what it gets from this match action and instructions, right? And then hand the packet over to the first service. Okay. Then the service would basically send the packet over to, once it's done with its processing, if the packet is not dropped, for example, it would come to this dispatcher table again, okay? And the interface manager would basically bump up the service version. So after service 1, it would go to service 0, it would go to service 1, and so on and so forth, right? 2 would lead to 3, okay? Linear bump up of the priority, as well as change of the metadata. So any service specific instructions on the port, as well as the services independent tag that needs to go in the packet itself, would be put in the metadata, right? So that's how it would basically send the packet through every services pipeline, right?
In order to be a good citizen, is it a good idea for a service to not drop the packet?
Not necessarily. It could decide to drop, or it could decide, yeah. So this is assuming the service has not dropped the packet. It is of course a higher priority, right? Right.
Yeah. I was thinking if you make a generic stuff and then nothing goes to automatic in this guy's control. So obviously I understand the security implications.
ACL is
Yes.
fine.
Correct.
Applications say, okay, that's it, I don't care. I just don't
Correct. I mean, they do need to play nice. For example, even in the metadata, or the OpenFlow tables resources that have been handed to them, they need to play nice and stick within their boundaries, right? So finally, there is some. You could add some level of validation in future, but we don't have that. Applications are expected to cooperate and work in that framework. Yeah.
It's a good idea. I mean, it's better for the service to play nice.
Yes. Yes.
I mean,
Correct.
this also includes not only the packet in the service index has to be changed by
Pumped
the
up.
application and then
Then only
given
that.
back. Given back. Because I have processed okay in the service.
Exactly.
Correct. Correct.
Because that's this particular issue, sir.
No, but that happens in the dispatcher table, right? The bump up of the
Bump
service.
up, but my current service, right?
Correct. So it'll let the packet through its pipeline, get it back into the dispatcher table, and then you bump the service up, right?
But
Yeah.
that service has used up the metadata for something else.
Yes.
It has to clear it back.
Correct.
Back and
Correct.
just
Yeah.
fix it.
Yeah.
Who has to clear that? The service, or should the interface manager clear that metadata?
No, suppose, let us say the metadata was written here, right? The IF index and service index and given to that service one. And service one, due to lack of space, it used up that information. I mean, that's put it by from metadata, whatever. Right? But when it giving the packet back, it has to set up a metadata, to whatever it was when the packet was given. That's how it has to be a nice design.
Yeah.
Two questions. So then, assuming this is going to be the case, service 1, service 2, we need NetBird and SFC.
Correct.
I'm assuming service 1, let's say it's NetBird, and
Mhm.
NetBird has whatever, 10 tables, table 0.
Right.
Handle.
Right.
How does NetBird know where to start writing its code? I'm assuming you're telling him you are from tables 10 to 20.
Yeah, so that would be in the control plane. When the service binds itself to the interface manager, it would request, so either if it's a static priority, it would know that this is SFC and I need, 10 tables for SFC, and it would give those tables to SFC in the
So
runtime.
you
Right.
tell us back, okay, you're
Yes.
table 50 to 80.
Correct, correct. So it would tell them.
To send the packet back,
Mhm.
when NetBird or SFC is finished,
Yes.
send it back.
Yes.
I'm assuming we have to do a resubmit to send it back.
Yes, it's a resubmit action, correct, yeah. So after every service, by default, the packet goes into this service dispatcher table to figure out which services. So let's say this service was not registered in the data plane, then you would go directly from service 1 to service 3, and you would skip all those other tables in the pipeline. So I think that part is missing in network today, right? You always go through that. So all the layout of this table would all be based on how the service bind framework is working in the control plane, and then in the data plane, this is how it would sort of flow.
And then metadata, that's not what registers, it's just the older metadata.
Yeah, correct. So, but that can be sort of adjusted, right? It's the basic concept is that the interface manager will put that metadata in here and give it to the service. Yeah.
That's the only field, right? You write into that, service does whatever, you just gotta make sure it's still there when it comes back out. But that's the only field, everything else.
Yeah. So we'll need to figure out if the service needs to keep that or interface manager can work. I mean, today that's how it is, but that can be changed. Yeah, that can be changed. Correct. Yeah, right now that's how the implementation is. But interface manager could very well decide, it doesn't care, it doesn't depend on what the service has done, and just put the same information here as well, right? Yeah. So that's possible. So does that kind of answer your question, Brady and Andre, on how different services might coexist in this sort of framework?
Yeah, I think it's just done the same thing that we've done, but it's put in a dynamic or an interface.
Correct, in a more API-driven manner, so that you don't have application level coordination. That's the main idea, I guess. Correct.
More like OpenFlow application governance.
Yes, it's a broker. Yeah, it's a broker. Yeah. So in the control plane as well as data plane. So that's how you sort of. So as you add more and more applications, or you have two applications doing the same thing, this framework can come in use there to decide how to.
The idea is not just for OpenFlow, it is going to be generic.
Correct. So given that this is there, then we come to how does it fit into.
It's still,
Not entirely clear on how you would piece together the different applications or services.
So-
table zero, man, it automatically goes, it's adding like an extra hop. Like right now, we
Correct.
use table zero and match on the NSH headers. Right now, you would have to be the first service, so they're our priority. So we would just bump into SOC looks at it, is that an NSH header? No. Okay, go back.
I wouldn't think it would get to SFC. It wouldn't get there.
It's got to go through the pipeline, right?
No, if it doesn't have an NSH header, it would not come
Was
to
there
SFC
enough?
yet.
Was there enough?
No, so NSH, whether the NSH, so that would need to be something that SFC would need to let interface manager know that you define an NSH header type interface, okay, and then the interface manager would here determine if there is some NSH header present or whatnot, and then based on that it would basically give it to this service, SFC, yeah. So yeah.
Well, but there's some cases where, depending upon what's in the packet, in some cases, even if it has an NSH header, sometimes, it could be going to SFC, but if it was the last hop, and it was going to the egress classifier, then it needs to go to the network. And so you would need to look at the context within the packet to decide.
Yeah.
But those, it might be the case that it's a little less efficient, but if it has an NSH header, it always goes
Correct.
to SFC first, and then SFC says, okay, well, no, this was,
Yeah.
I've already handled this, I need to,
Right.
resubmit to network. I guess that's.
So the idea is that all the business logic.
We're about to get kicked
Have
out.
to be a little
Oh,
careful
okay.
how much you
Yeah.
use this. I don't think
Yeah.
you want to use this for every individual little service, because I suspect that it will add a performance hit.
Yeah,
Every table lookup, I mean, this is just software.
correct.
And every table lookup is extra,
Right.
instructions.
But the core idea, correct. Yeah, but the core idea, Andre, is the business logic of the service has to belong in the service. You should not let that percolate in here, right? So this has to be a more generic framework, and let the business logic of the service decide what it wants to do, and if it doesn't, care about the packet, hand it back to the other service, to the next service down the line.
Can be
That's-
part of internet-driven programming.
So.
You can
Maybe
also
just
log-
quickly, just 1 minute to quickly. So this just basically has, talks about how this renderer framework could come in. So we just added like one slide to talk about it, how you can have different southbound renderers, and we can discuss this in a more, maybe we take it up later. Yeah, it's already time up. So we talk about the other services to some extent, but those are more support services. The interface manager would be sort of the main one that maybe we spend a little bit more time going over ID manager when we go into implementation aspects. Yeah. Okay. Thank you.
Thank you.
Thanks. Right.